Hey guys, welcome back again to the Maths Club. If you are just joining us, so welcome, and if you are returning, welcome back. It's nice to see you here again. In this particular video, we're going to be looking at quadratic graphs. In the previous video to this, we looked at linear graphs. So let's just get started. When you say a function y is equal to ax squared plus bx plus c, that should strike you as a quadratic equation. Why? Because the highest power of x is 2. So any equation at all that you see that the highest power of x is 2 is a quadratic function or a quadratic equation. So let's do a small trivia. Which of the following are quadratic equations? Is this a quadratic equation? Let's see if what you actually said is correct. No, it's not a quadratic equation. Why? Because the s power of x is what? 3 in this case. This is a cubic equation. Is this a quadratic equation? No, because the s power of x is what? 1. This is a linear equation. Is this a quadratic equation? I'm sure you're confused, right? Because what I showed you here was ax squared plus bx plus c, but you're not seeing anything like bx here. As far as the s power of x is 2 in that equation, that is a quadratic equation. Great. So let's look at quadratic graphs. A quadratic graph is really a parabola, and you will see the shape in the next slide to this. The vertex is like the highest point or lowest point of the parabola. So if you have the parabola, the highest point is the vertex, or the lowest point is actually the vertex. Then there's an axis of symmetry. Symmetry is like equal, like two equal sides, like something that divides the parabola into two equal halves. So that axis, that straight line, just like when you want to cut cake, you know, you and your sibling, you want to cut cake, you don't want to cheat anyone, you don't want to cheat you, you carry a ruler, right, to put it along the width of the cake, and then you now find the middle, and then you slice it along that middle, right? That line that you're slicing through is the axis of symmetry. The axis where to the left and to the right it is equal width. Direction: the parabola can be upwards or downwards depending on the sign of a. So it is an upward opening parabola when the a is greater than 0. So you see that the shape of your curve will be something like this, like a U. It's a downward opening parabola when the a is less than 0. You see that it is downward. But where is the a coming from? If you go back to the slide before this, this is where the a is coming from. That is the coefficient of the x squared. So if the coefficient of the x squared is greater than 0, you would have an upward opening parabola, but if the coefficient of x squared is less than 0, you have a downward opening parabola. So look at this. This is the a here greater than 0 or less than 0? Great, it's greater than 0 because it is opening upwards. And you can see the line of symmetry. Line of symmetry is at x is equal to minus, so it divides that curve into two equal halves. You can see that this is equal, this is equal, this is equal, this is equal, right? And you can see the vertex, which is the highest point or the lowest point. In this case, this is the lowest point. And we can also see that this point, say this is the minimum value of, oh, there are a lot of information on this graph, but just follow me, right? You can see that this line here is the minimum value of y, because you can see the y value is coming, and this lowest can never be, then it comes up, right? What else again can we see from this? This is where it crosses this is like the y-axis, this is the x-axis. So this way it crosses the x-axis. You can see the x value here is -5, and the x value here is 1. You can see at y is 0, x is -5, or x is 1. Just like when you solve a normal quadratic equation, you have two roots now. You say x is equal to -5 or 1. So how do we know it? Where it crosses the y is equal to 0, that is where we get our x values, which are the roots of the equation. And then what else do we have? We have the y-intercept. So you can see this place here. This place here, this is the x value here is 0, right? So they trace it to the curve. Where did it hit the curve? It is the curve at this point. So here the x is 0 and the y is -5. So it's just a lot of information here which we are still going to break down, but this is basically what we have. And you can see the difference between an upward opening and a downward opening. You can see this is a downward opening because the value of the coefficient of x squared is a negative value, and this is upward because the value of the coefficient of x squared is a positive value. So to find the vertex is the point h, k. You can find the h, which is like the x-axis, right, using the formula minus b over 2a. Once you have the x-axis, which is this h, you can now find the k, which is the y value, right? So you can find the y value by substituting the x value, which is h in this case, into your equation. We're going to see all of this in action. So let's see an example. We're told for y is equal to 2x squared minus 4x plus 1, we should actually find the vertex position. So we know our vertex position is h comma k, and we know that to find h we can say minus b all over 2a. What is a? A is in this equation is coefficient of x, which is 2, and b is coefficient of x, which is what's minus 4. So let's substitute. So h will now be equal to minus 4 all over 2 times 2, right? Minus as minus is plus, that will be 4 all over 2 times 2 is 4, so that will give you 1. So my h is 1. I can find my k, right, by substituting it into this equation. So anywhere I see x, I'll put 1, and then I'll find my k. Remember, k is same thing as saying y. So k is 2 open brackets 1 squared minus 4 times 1 plus 1. 1 squared is 1, so 2 times 1 is 2, so k is equal to 2. 4 times 1 is 4 plus 1. 2 minus 4 is minus 2 plus 1 is minus 1, so my k is minus 1. So therefore my vertex is 1 comma minus 1. So just think of h as x and k as y. So you can see the h is 1, the k is minus 1. Axis of symmetry, we said it before, that it is the line that divides the parabola into 2 equal halves, and if you look at it, it's also the same as the x value that you will have gotten from the previous one where we're trying to find the vertex. So that means that the points where you find the vertex, right, the x value there is really just the line that your axis of symmetry, which is that line as if you are cutting the cake into 2, would pass. That is what all of this is saying. So in that previous example, the axis of symmetry is actually just up, like that line. You draw the vertical line at the point x is equal to 1. So basically we substitute a and b to find a value of x. An example is y is equal to x squared minus 6x plus 8. So you can solve this by yourself. When you do that, to find out that the axis of symmetry, the x value is 3. So at x is equal to 3, you can draw your line and divide that cake into 2 equal halves. And before I continue, if you have found this video useful up to this point, like the video, help my ministry. If you are not subscribed, subscribe to this channel, and if you have any question, drop it in the comment section. I'll respond to all questions. So let's continue. Gradient is how steep a line is, right? And then the gradient of a quadratic function, it changes along different points. So most times what you see in the question, you say find the gradient at the point x is equal to 2, find the gradient at the point x is equal to 3, because the gradient at each point is different, and you see how we're going to plot it and find the graph at a given point. So the gradient of a quadratic function at any point x is given by the first derivative. So if you have something like this, y is equal to ax squared plus bx plus c, if I've done the y dx before, you see that this is not a class I'm going to teach the y dx. You can check that out on the internet. There are a lot of videos that will teach you how to find derivative. So if you have ax squared, the derivative of ax squared is 2ax, derivative of bx is b, derivative of c is 0, derivative of a constant is 0. Right, so you can check that out. It's taking like 5 minutes to check it out. Then when you have this guy, you can now substitute the value of your x and say, okay, at the point maybe x is equal to 3, what is my derivative? We'll solve it together. We'll solve a question and we'll see how this formula applies. So if the derivative is greater than 0, the function is increasing, but if the derivative is less than 0, the function is decreasing. These are some things that you just need to know. And then if it's equal to 0, the function has a horizontal tangent. Now let's get to the real crux. So we're told to complete the table, right? And then we're given a scale of 2 centimeter to 1 unit on the x-axis. Please note all these things I'm saying. And 2 centimeter to 5 units on the y-axis. You can write it down somewhere. Given that, we're told to draw the graph, and then using the graph, we'll find the roots of x squared minus 2x minus 2 is equal to 0, the value of x for which x squared minus 2x minus 4.5 is equal to 0, and the equation of the line of symmetry of the curve. This is taken from 2005. We're going to solve this together. So they've given us at x is equal to minus 4. So let's find at x is equal to minus 3. So anywhere I see x here, I'll substitute minus 3. Let me just shift a bit upward. Okay, great. So my y will be equal to minus 3 all squared minus 2 open bracket minus 3 minus 2. So minus 3 all squared is 9. Minus 2 times minus 3 is plus 6. Then minus 2. 9 plus 6 is 15. 15 minus 2 is 13. So my answer here is 13. So at x is equal to minus 2, y will be equal to minus 2 all squared minus 2 open brackets minus 2 minus 2. Minus 2 all squared will give you 4. Minus 2 times minus 2 will give you plus 4. Then minus 2. So 4 plus 4 is 8 minus 2 is 6. So this value here is 6. So at x is equal to minus 1. So that will be y will be equal to minus 1 all squared minus 2 open brackets minus 1 minus 2. Minus 1 all squared will be 1. Minus 2 times minus 1 will give you plus 2, then minus 2. Plus 2 minus 2 is 0, so my answer will just be 1. So this guy here is 1. So at x is equal to 1, that will be y will be equal to 1 all squared minus 2 open brackets 1 minus 2. 1 squared is 1, minus 2 times 1 is minus 2, then minus 2. 1 minus 2 is minus 1, minus 1 minus 2 is minus 3. So this guy here is minus 3. Then at x is equal to 2, that will be y will be equal to 2 all squared minus 2 open bracket 2 minus 2. 2 all squared is 4, minus 2 times minus 2 is minus 4, then minus 2. So 4 minus 4 is 0, 0 minus 2 is minus 2. So our answer here is minus 2. So that is, now that we have the points, we can go ahead to plot our graph. So this is the graph of y is equal to x squared minus 2x minus 2. And on the x-axis, we're told that 2 centimeter represents 1 unit, and then 2 centimeter represents 5 units on the y-axis. Right, so given this, we can now plot our graph. The lowest value of x is minus 4, the highest value of x is 4. So that means that I have to put a point that will give it space at the left and space at the right. So let me just use my eye and do like this. So this is minus 1, 2, 3, 4. Okay, so this should work. I'm using biro so that you can see it very, very well. So this is the y-axis. And then for the y-axis also, the highest value of y is 22, the lowest value is minus 3. And because I'm using 5 units, so I can just look for somewhere here and say this is the 0th position, this is minus 5, this is minus 10, and I'm covered. So 5, 10, 15, 20, 25, 30, 35, 40, right? So I can now draw my x-axis now. So these are x-axis. So when x is minus 4, okay, I've never labeled the x-axis, so that will be minus 1, minus 2, minus 3, minus 4, 1, 2, 3, 4. So when x is minus 4, y is 22, so minus 4, this is 20. How do we know how to count? There are thin lines in between here, and from here to here is 5, 5, 5. So I could just say 5 divided by 10 is 0.5. So as I'm moving each line, I'm moving 0.5 units away. So 20 is 20, 20.5, 21, 21.5, 22. So this is where I'm coming to. So minus 4, 22. Always very careful about your points. That is the first place we make a lot of mistakes. Minus 3, 13, minus 3, this is 10. So but this 15, I can come from the top. 15, this 14.5, this 14, 13.5, 13. So this point here. Every time I mark 2 points, just to make sure that I'm going to use pencil to just draw a faint line to join each of them. The reason being that if you are drawing the curve can go anywhere. I mean, I'm going to use French curve. Some parts could be very wide, some parts could be very big from 2 different people. But when you use something like very faint, like a pencil line, and use straight line, it's going to help you in your outline so that you are getting something very accurate or close to accurate. Minus 2 is 6. So minus 2 is 5, 5.56. Minus 1 is 1. Minus 1, 0.51. So this is it. So let me just join with a very faint pencil line, very faint, just to guide me. You will never be able to see it because I don't know if I can see it very well. Right, 0 to minus 2, 0, this is minus 0.5, minus 1, minus 1.5, minus 2. So this point here, so I'll just the very faint pencil line. Okay, 1 to minus 3, 1 to minus 3, 1, this is minus 5, minus 4.5, minus 4, minus 3.5, minus 3. So this is what I'm coming to. So with another very faint pencil line. Great. So 2 minus 2. So this is minus 2 already from one of the previous points. And 3, 1. So this is 0.51. 4, 6. So this is 6. So I'll just join them with just a very faint pencil line. Very faint. Great. I have a rough estimate of how the outline would be like. Right, and I can use my French curve and ensure that it does not go beyond that outline. Right, so I'll just join these 2 points, ensure that it's still like within the perimeter of that line. Great. Then come and join these 2 points. But first, I'm going to ensure that this line here, this one here, is in line with this previous one. So I'll just join it here. Okay. Then here again, I will join these 2, ensure that it's still in line with this old line that I'm drawing, and then it's still within the bounds of the straight lines that I drew. This might take you a bit of time if this is your first time of using French curve, but that is very fine, I assure you. So I'll show that it's also in line with this place, and then it's touching the 2 points. Great. And it's in line with that my faint line that I drew. Beautiful. So I'll come again and see. Is it in line with this one? Is it in line with that my faint line? And is it touching those 2 points? Yes. So I'll draw. I'll come here again. Is it in line? Yes, it's in line. And is it continuing from this previous one? It wasn't continuing at the point 2, but let me adjust it. Okay, and it's in line, so I'll join. Right, I'll come again, continue from this previous line, and it's in line with that my faint line. I will draw, and then from here I will connect. So this is our graph. You might not appreciate the faint lines that I drew until one day you draw it and then you start having values that are far off. Then you will know. Right, so this line of y is equal to x squared minus 2x minus 2. You must label it. The question now says that we should find it says that we should find the roots of the equation. The roots of the equation is when this our graph is equal to 0, which is x squared minus 2x minus 2 is equal to 0. Where is equal to 0? Is equal to 0 here, and is equal to 0 here. This is this is like 10 lines, and this one, so that will be 1 divided by 10, which is 0.1. So I'll come and say minus 0.9, minus 0.8, minus 0.7. So y is equal to 0 at x is equal to minus 0.7, or, so I'll just put it minus 0.7, or this position here, this 3, 2.9, 2.8, 2.7, or x is equal to 2.7. So we are done with that particular one. Then the next question now says that x squared minus 2x minus 4.5 is equal to 0. We should solve this. Our equation is x squared minus 2x minus 2, but what we have is minus 4.5. I could just say x squared minus 2x. I could write that, say minus 2 minus 2.5 is equal to 0. Do you believe that will be correct? Yes, because minus 2 and minus 1.5 will give me minus 4.5. So I'll carry over this minus 1.5 to the other side. So that will be x squared minus 2x minus 2 is equal to 2.5. So I have the curve of x squared minus 2x minus 2. I have to just find the point where it is equal to what? 2.5 or 2.5. So let's go. So this is the y value, right? I'll just find the place where the y value is 2.5. This 0, 0.5, 1, 1.5, 2, 2.5, right? 3, 3.5, 4, 4.5. Okay, great. So this is it. Then I will just slam it against this place and find out where it's going to touch the curve. It's touching the curve at 2 places. So I'll just draw a dash line. So this is my point 2.5. Then I'll trace it to the x-axis. The point where it touches, and the point where it touches this place too. 1, 2, 3. Right? So this is minus 1.1, minus 1.2, minus 1.3. And this is 3.1, 3.2, 3.3. So you can see that for this my particular solution, I said x squared minus 2x minus 3 will be equal to 2.5 at x is equal to minus 1.3, or at x is equal to 3.3. Right? So one thing I need to just state is that it is not equal to, this is approximately. Because you cannot be sure that what you got is actually the correct thing. So don't put equal to, put approximately. Thank God I remember that. So I could say y is equal to 2.5 at x is approximately equal to minus 1.3, or at x is approximately equal to what? 3.3. 0.3. So it's either at this point or at this point. That is where we'll have our x to be equal to, or that's where we'll have our y to be equal to 2.5. Then the last question also is that we should find the line of symmetry. As discussed, the line of symmetry is just the point where the curve is divided into two equal halves, right? Or which is like the vertex, is that also at the vertex. So the vertex is minimum point. So you can see this is the minimum point here, right? So I can just trace it up. Let me just even draw a line. I'll just draw a line here and show you that this is my line of symmetry. And line of symmetry occurs at which x value? At where x is equal to 1, is at x is equal to 1. So that's basically the solution to this particular question. Simple and short. So the next example now says that we should copy and complete the table of values for y is equal to sine x plus 2 cos x, correct to one decimal place, using the scale of 2 centimeters to 30 degrees on the x-axis. Always knows the scales. Don't go and do what they did not tell you to do. And 2 centimeters to 0.5 units on the y-axis. Draw the graph of y is equal to sine x plus 2 cos x for x between 0 and 240 degrees. So you can see they've given us 0 and 240 degrees. They've given us a boundary because the graph could go on and on and on like that. They've given us a boundary for us to work with. And then using the graph, solve the equation. Sine x plus 2 cos x is equal to 0. Sine x is equal to 2.1 minus 2 cos x. And then from the graph, find y is equal to. And then from the graph, find y when x is equal to 171 degrees. This is taken from WAEC 2009. Let's solve it together. So the same thing too, we're going to complete this table. So when x is equal to 0 degrees, so this will be y is equal to sine 0 plus 2 cos 0. So sine 0 is equal to 0, cos 0 is equal to 1, so 2 times 1 is 2. So this answer is 2, so 2.0, because we should do it in one decimal place. So this is 2.0. And then when x is equal to 60 degrees, so y will be equal to sine 60 plus 2 cos 60 degrees, right? So we can just plug it in and say sine 60 plus 2 cos 60. So this will give you 1.9 if you are doing it to one decimal place. So 1.9. So here is 1.9. So when x is equal to 90 degrees, our y will be equal to sine 90 plus 2 cos 90 degrees, right? So these are the degrees. I meant to put the degrees here. So 0 degree, 0 degree. So sine 90 is 1 plus cos 90 is 0. So this 2 times 0 is 0. So our value for y here is 1. Then when x is equal to 120 degrees, we'll say y will be equal to sine 120 degrees plus 2 cos 120 degrees. So you can just plug that into your calculator. I had minus 0.1, right? And then when x is equal to 210 degrees, so our y will be equal to sine 210 degrees plus 2 cos 210 degrees. So that gave me minus 2.2. So this one that is 1, that means 1.0 because that's one decimal place, right? So I have to maintain consistency. I didn't put the answer. This is minus 2.2. Even this one, if I didn't put the value of y, so let me just put it there. When it was 1, that was minus 0.1. Great. So we can go ahead to solve this question. So this is the graph of y is equal to sine x plus 2 cos x. And we're told in the question that 2 centimeter represents 30 degrees for the x-axis and 2 centimeter represents 0.5 units for the y-axis. So our lowest value of x is 0, our lowest value is 240, so I can just maybe just put something like this, all right, to give enough space for the x-axis. So these are y-axis, and then for the y value, the lowest value is minus 2.2, the highest value is 2.2 because it's 0.5 units. So I could just say somewhere here 0.51, 1.52, 2.5, 0.51, 1.52, 2.5. So this is good. So this is 0.5, this 1.0, this 1.5, this 2.0, this 2.5, this minus 0.5, this minus 1.0, minus 1.5, minus 2.0, minus 2.5. So I'll draw this line 2 for the x-axis. So these are x-axis. I could just come here and see these 30 degrees, 60 degrees, 90 degrees, 120 degrees,
150 degrees, 180 degrees, 210 degrees, 240 degrees. Remember, everything we're getting here is going to be approximate. So you might not get the exact value, you might get, depending on how accurate your curve is. So 0 degree is 2.0, 30 degrees is 2.2. I'm sure now you can count all these guys. So for 30 degrees, I'll say 2.2, this is 2.0, 2.05, 2.1, 2.15, 2.2. 60 degrees is minus 1.9. 90 degrees is 1.0. 120 degrees is minus 0.1. 150 degrees is minus 1.2. This is minus 1.1. This will be minus 1.2. 150 degrees, okay, that's 150 degrees. 180 degrees is minus 2.0. 210 degrees is minus 2.2. This is 2.1, 2.1, 2.2. 240 degrees is minus 1.9, which is this guy here. Great. So just to join them. I'm not going to be joining straight lines. I'll just trust my intuition is correct. So let me join these first two guys. Then join it with this other guy. Okay. Then this place here too. Join it with this guy. Here, join it with this guy. It's already sloping outwards, so I'll just change the direction of my curve. It's kind of doing like a snake this thing, so I'll just join it here. Great. Then let me join it to this one here. Then I'll join it to this one. So you can see I'm very fast with the French curve because I've used French curves before. So if I need to French curves, you might struggle a bit, but that's very fine. So I'll just join it here. Then for this one too, I'll join it here. So this is our graph of y is equal to sine x plus 2 cos x. Great. So from the question, we're told Ci that we should find what? The root, which is sine x plus 2 cos x is equal to 0. This y is equal to 0, where it's the x-axis, like we said before. So these, if each of these guys are 30, 30, so each of these guys is 3, 3. So this is 120, this will be 117 degrees. So our y is equal to 0, where x is equal to 117 degrees. So for Ci, we're told sine x is equal to 2.1 minus 2 cos x. So let's now rearrange. So that will be sine x plus 2 cos x will be equal to 2.1. So we have sine x plus 2, which is the curve that we have here. And we're told to find where is that value equal to 2.1 on the y-axis. So this is 2.0, 2.1. So if this is 2.05, this will be 2.1, right? So if that's 2.1, I just have to trace it to the x-axis. So I'll trace it, and then I'll trace it down too. I'll also trace it down too. So yeah, this guy will be 3, 6, 9, 12. This is 12 degrees. And this is 33, 36, 39, 42, 45, 48 degrees. 40 degrees. Remember, like I said, these are approximate values, right? So we could say, so instead of me saying equal to here, I should have changed this to approximately equal to. Please take note of that. So y is equal to 2.1 at x is approximately equal to 12 degrees, or x is approximately equal to 48 degrees. And we can try that out and see what to give us when we plug this in our calculator to see if we're correct. So this is my calculator here. I could say sine 12 degrees plus 2 cos 12 degrees. So this gave me 2.16 something. Fine, I'm not bothering my head. Then this 48 degrees. This 48 degrees. This 2.08, which is approximately 2.1. So I'm fine, right? So this is how you just know that your answer is a bit correct. I know I told you there are always ranges. Whatever answer you get, there's always a maximum or minimum range that your answer must fall in between for your answer to be correct. So the last D says that we should find the value of y, or which is, question D says that find the value of y when x is equal to 171 degrees. So when x is 171 degrees, what is that? This is 180, 177, 174, 171. So this is 171. Just to trace it down to meet the curve, but it's only meeting the curve at only one place here, and then to trace it to the other side. So let's go. Let me trace it to the y-axis. So this is minus 1.55 minus 1.6 minus 1.65 minus 1.7 minus 1.75. So this what position is this? This is where our x is 171 degrees. So I also name this place. This is where our y is 2.1, right? So x is 171 degrees, where y is equal to minus 1.75, right? From the graph, all of these guys are from the graph. So this is the solution to this particular question.
Example 3 says that we should copy and complete the table of values for y is equal to 3x squared minus 5x minus 7. Use a scale of 2 cm to 1 unit on the x-axis and 2 cm to 5 units on the y-axis. Draw the graph, and they've given us a boundary. Our boundary was between minus 3 and 4 inclusive. From the graph, find the roots of the equation, estimate the minimum value of y, calculate the gradient of the curve at x is equal to 2. So I encourage you to actually solve this particular question at least up to CI, right? And then look at what we do for II and III. Welcome back. Let's solve it together. So when x is minus 2, that will be 3 open brackets minus 2 all squared minus 5 open bracket minus 2 minus 7. 3 times minus 2 all squared is 4. Minus 5 minus 2, that will give you plus 10. Then minus 7. 3 times 4 is 12. So 12 plus 10 minus 7, that will be 22 minus 7. Right, 22 minus 7 is 15. So the answer is 15. Then when x is equal to minus 1, that will be 3 open brackets minus 1 all squared minus 5 open bracket minus 1 minus 7. Minus 1 all squared is 1 times 3, that will give you 3. Minus 5 times minus 1, that will give you plus 5 minus 7. So 3 plus 5 is 8. 8 minus 7 is 1. So the answer here is 1. When x is equal to 2, that will be 3 open bracket 2 all squared minus 5 open bracket 2 minus 7. This will be 3 times 4 minus 10 minus 7. 3 times 4 is 12. So 12 minus 10 minus 7. 12 minus 10 is 2. 2 minus 7 is minus 5. So answer here is minus 5. And then when x is equal to 4, so that will be 3 open brackets 4 all squared minus 5 open brackets 4 minus 7. 3 times, okay, let's break. 4 squared is 16. So 3 times 16. 5 times 4 is 20 minus 7. 3 times 16 is 48. So 48 minus 20 minus 7. 48 minus 20 is 28. Minus 7 is 21. So our answer here is 21. So these are table of values all completed. Let's go ahead and plot this graph.
So this question, we want to solve y is equal to 3x squared minus 5x minus 7. I'm told on the x-axis, the scale is 2 centimeters to represent 1 unit, and 2 centimeters to represent 5 units on the y-axis. This first one's for the x-axis, second is for the y-axis. The lowest value of y is minus 9, the highest value is 35, lowest value of x is minus 3, highest value is 4. So I need to find something that will be equitable. So if I come here and I draw this minus 1, minus 2, or 1, 2, 3, 4, this should be fine. So these are y-axis. And by using 5 units, but 35 and minus 9. So if I choose here, 5, 10, 5, 10, 15, 20, 25, 30, 35, this will be fine. Right, so these are point 0. So I'll draw my x-axis. So this is the x-axis. So this is 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4. This is 5, 10, 15, 20, 25, 30, 35. And this is minus 5, minus 10, minus 15. So when x is minus 3, y is 35. So minus 3, 35, we have it here. Minus 2, 15, minus 2, 15, we have it here. Minus 1, 1. So this is minus 1. I already told you that you can calculate all of all this, so this is minus 1, 1. So when x is 0, y is minus 7. So this is 0, this is minus 5. Minus 5 over minus 6, minus 6 plus 5 minus 7. When x is 1, y is minus 9. 1 minus 9. X is 2 minus 5. 2 minus 5. 3, 5. And then 4, 21. Great. So it's just a join of all these points together. So I'll use my French curve and join. So let's see these first 3 points. If I can be able to get 3 at a time. I doubt. Let me not be greedy. Then here. I think it works. Yep. Then let me join it from this place here. I'll join it from this place too. Let me even join this 3 bottom. So I join this 2 with the smaller one. Then I move up and join this 2. Then I'll join this one. Let me use the bigger one. I think I can use the bigger one now. Yes. So I'll join this place. So we have our graph. This is our graph of y is equal to 3x squared minus 5x minus 7. Always try to make your graph neat. Right, just try. I know it's not going to be easy at first, but you keep on improving. So the question also is that we should find the roots. So that is basically where 3x squared minus 5x minus 7 is equal to 0. So where does it equal 0? It equals 0 at this point. The y value is 0 at this point. The y value is 0 at this point. So this is 1, 1, 1, 1. So this would be minus 0.9. And this would be 2.1, 2.2, 2.3, 2.4, 2.5. 1, 2, 3, 4, 5. So this is 2.5. So y is equal to 0 at x is equal to minus 0.9, approximately equal to minus 0.9, or x is approximately equal to 2.5. So D now says that we should find the estimated minimum points of the y value, right? So the estimated minimum y value is, let's look at this point. This is the curve, right? So if you look at this place here, if this is minus 10, this would be minus 9.5, this would be minus 9, right? So if I want to estimate it, right, my own estimate is minus 9. Your own might be something different, but there is also a limit that they're looking at. So as far as I'm sure all of us will fall within that limit. So this will be minus 9. So is minus 9.0, right? Then it now says that from the E, that from the graph, we should find the gradient at x is equal to 2. So you can say the gradient at x is equal to 2 is, so we point this down to this point here. This is point 2 at x is equal to 2. So we drag it down to where it touches the curve, right? And then where it touches the curve, at that point, we draw a tangent to that point. A tangent is like a line that touches the curve. So just draw a tangent. Great. So this is how we solve it. When we draw a tangent, we now draw a rectangle just to be able to find our point 1 and point 2. So if I use this as my rectangle, let me just do somewhere like this. Okay. Now we said that the gradient changes along the line. So this is my point 1 and this is my point 2. At point 1, what is x? My x value is 3.1, 3.2, 3.3. What is my y value? My y value is 5. And then at my point 1, my x value is 1.1, 1.2, 1.3. And my y value is minus 10. So I will know that our m, which is the gradient, is changing y by changing x. So establish that from the linear graph. So that will be y2 minus y1 all over x2 minus x1. Our y2 is 5. Our y1 here is minus 10. Our x2 is 3.3. Our x1 is 1.3. So 5 minus 10, that will give me 5 plus 10 all over 3.3 minus 2.3 minus 1.3. So 5 plus 10 is 15 all over 3.3 minus 1.3 will give me 2. So 15 divided by 2 is 7.5. So our slope m is approximately equal to 7.5. Right? This value might be a bit far off from what the value is really, but it just depends on the points that you pick. Now, if we were not given the graph, we were told that we should find the gradient at a particular point. So I thought that there's an equation that we can use. First and first, so let me use the alternative approach if we're not going to use the graph. The alternative approach is saying that find the derivative of the equation. So our equation is y is equal to 3x squared minus 5x minus 7. And we said the derivative of this would be, you bring this 2 down, it will multiply the whole number, which will be 3 times 2. This x would minus 1. Like I said, I'm not teaching dy dx, so I might check the internet for any of all those videos. So minus the derivative of 5x is 5, the derivative of 7 is 0. So 3 times 2 give me 6x minus 5. This is the dy dx. So we want to find the dy dx at x is equal to 2. So dy dx at x is equal to 2. This would be 6 over bracket 2 minus 5. 6 times 2 is 12 minus 5. 12 minus 5 is 7. So our answer really, if we were to, the real gradient is actually 7. Or what 7.5, which is fine. Because at the end of the day, when the person is marking, they could have done plus or minus 0.5. So if your answer is within this range, then you're good.
Now, before now tells us that given this graph, we have to find the value of x for which x squared minus 3x is equal to 7. So this particular kind of questions are always very sweet because it's more visual. If you look at this place here, we just have to point where this graph, because this is the, okay, this is the graph. The graph is x squared minus 3x minus 3, but we're told x squared minus 3x is equal to 7. So we have to first write in terms of this. So that will be x squared minus 3x, carry this on to that will be minus 7 is equal to 0, right? But I need minus 3, so that will be x squared minus 3x minus 3 minus 4 is equal to 0. So that will be x squared minus 3x minus 3 is equal to what? 4 by carry over. So now we have the equation, you can see, in terms of what we have. So that is x squared minus 3x minus 3. So basically what we're trying to find is where this value here, like this curve here, is equal to 4. And that is this point. That is this point here. And this point, because if we draw that line, I don't know if I'll be able to draw a line. Great. If we draw the line, we'll see that this is the point, and we'll just have to trace down the value, right? So we just have to trace down the value. I'll have to trace down the value here and find the approximate. So that would be like, let's say, based off of what we have here, this would be like minus 1.55, and this place here will be like 4.55. So that would be our option A. Simple and short. Once you know what you're doing, it is very easy. I mean, I think I even did this. I could have said, instead of saying it's equal to 7, like I said, it's equal to 3 plus 4, right? And carry over this 3 to the other side. That will be x squared minus 3x minus 3 is equal to 4. And I will have had this instead of me going through all these long routes. But that's how you actually solve this particular question. Let's see if our answer is correct. Option A, great. Minus 1.55 and 4.55. Simple and short. This is taken from WAEC 2011. Example 4 now says that given that same question, what is the equation of the line of symmetry of the graph? No, I told you that the line of symmetry occurs at the vertex. So just know what the vertex is, and this is the vertex. Vertex is like the maximum or the minimum point of the graph. So this is the vertex here. So if you trace it, this is like somewhere here, right? Remember, the equation of symmetry is the x value, which is x, which is equal to, let's say, 1.5, right? 1.5 is always the x value, never the y value. Don't be carried away. It's always the x value. So that will give you option C to be your answer. Also take it from WAEC 2011. With this, we've come to the end of quadratic graphs. I mean, quadratic graphs are actually very, very interesting. So when you see questions like this in the objective, it's just a cheap question, very cheap question for you to solve and get your answer. Once again, if you found this video useful and you've not yet liked the video, you want me to be a pain in your dreams, please like the video, comment if you have any question, any contribution, any suggestion to improve our delivery, and then share the video to somebody, like share the link of the channel to somebody. Let others benefit from what you're benefiting from. And then I'll see you guys in the next video. Bye for now.